Hi everyone. In this video we are going to talk about quadratic equation. Here we are going to learn what a quadratic equation is, and also we are going to learn various types of polynomial functions that we have in algebra. So let's get started. Now if we have to define quadratic equation, it is nothing but a second degree polynomial equated to 0, right? So in general we can say that if we have a second degree polynomial, so let me write it down here. Second degree polynomial equated to 0, that is a quadratic equation. Now let's try to understand what are the different types of polynomial functions we have, right? So now I'm going to show you the general form of a polynomial function, and we could even call it a p of x or even f of x. I generally prefer the f of x, so let's go with the f of x notation. So if we have a polynomial function f of x, it's going to look like this: a sub n x to the power n plus a sub n minus 1 x to the power n minus 1 plus a sub n minus 2 times x to the power n minus 2 plus etc. It will go on like this, and then finally I'm going to write down the last three terms. So maybe I can try it right here. So let's suppose a sub 2 x squared plus a sub 1 x plus a sub 0. On the last term, the power of x is 0. That's why I did not write it, because x to the power 0 will be 1. So it's same as not showing the x to the power 0, right? So I simply wrote a sub 0. So this is the general form of polynomial function. Now let's try to learn a couple of new terms here, terminology rather. Now whatever coefficient we have right here, all of these, like a sub n minus 1 or a sub n minus 2 or even these ones, they are called coefficients of x, right? Whatever the power of x might be, but it is called coefficient of x. They are called coefficient. And then if you think about the very first term, which has the highest power of x, this coefficient, the a sub n, it is called the leading coefficient. And the very last term, where we do not have any x in the term, meaning you see this one, the a sub 0, where the power of x is 0. That's why you are not seeing the x, because x to the power 0 is actually 1. So this term is called the constant term. Let's take a few special cases. Case number 1, when all of the coefficients are 0, even including the constant term. Even if when all of the coefficients are 0 and the constant term is also equal to 0, then we can clearly see that if a sub n is 0, then this term becomes 0. If a sub n minus 1 is also 0, then the second term also becomes 0. Similarly, all of the terms will become 0, and finally we are also saying that a sub 0 is also equal to 0. Then f of x becomes equal to 0. So f of x becomes 0, and this form is called the zero polynomial. This is known as zero polynomial. Now let's take a look at the second example, where all of the coefficients other than the constant term are 0. For example, a sub n is equal to 0, a sub n minus 1 also 0, a sub n minus 2 also 0, all the way up to a sub 2 is also 0, and a sub 1 is also 0. Then you see all of those terms become 0 except for the constant term, which is not equal to 0. And in that case, f of x becomes equal to a sub 0. And this type of a polynomial function is called a constant polynomial. Now let's talk about the third scenario. Now let's take a scenario where all of the coefficients are 0 all the way up to a sub 2. So a sub n minus 1, a sub n minus 2, all the way up to a sub 2, all those coefficients are 0. That means all those terms become 0. So we'll be left with a sub 1 times x plus a sub 0. So then f of x going to look like this. It will be a sub 1 times x plus a sub 0. And when you see a polynomial function like this type of polynomial function is called linear polynomial. Now let's talk about the next scenario, number 4. Now let's take a scenario where all the coefficients starting from a sub n all the way up to a sub 3. Even though I have not written the a sub 3 term here, but you can imagine that right before the a sub 2 term, we have the a sub 3 term. So if all of those coefficients become 0, then our polynomial going to look like this. There will be an x squared term and an x term and the constant term, right? So our polynomial will look like a sub 2 x squared plus a sub 1 times x plus a sub 0. And this type of a polynomial is called a quadratic polynomial. Now let's take another scenario where the coefficients are 0 all the way up to a sub 4, right? If the coefficients starting from a sub n all the way to a sub 4 are 0, then all those terms become 0. Then our polynomial function will look like this. It will only have the a sub 3 x cubed, this term, plus a sub 2 x squared, this term, plus a sub 1 times x plus a sub 0, right? And this type of polynomial function is called a cubic function, because here the highest power term has power 3 for the independent variable x, right? X has a power 3, so it's called a cubic polynomial. Now let's take the next scenario where we have all of the coefficients up to a sub 5 equal to 0. For example, a sub n would be 0, a sub n minus 1 is also 0, a sub n minus 2 all the way up to a sub 5, all those coefficients are 0. Then our polynomial function going to look like this. It will look like this: a sub 4 x to the power 4 plus a sub 3 x cubed plus a sub 2 x squared plus a sub 1 times x plus a sub 0. And when the highest power of x is 4, this type of polynomial will be called a quartic polynomial. It's called a quartic. Similarly, if we have a situation where all of the coefficients are 0 all the way up to a sub 6, then we are going to end up with a polynomial which is going to look like this. So I think I'll do this one other scenario and then we'll talk about the general form, right? So here our polynomial function will look like this when all of the coefficients up to a sub 6 are 0. That means all of the higher terms become 0 and we are going to be left with a sub 5 x to the power 5 plus a sub 4 x to the power 4 plus a sub 3 x to the power, or x cubed rather, plus a sub 2 x squared plus a sub 1 x plus a sub 0, right? And this type of polynomial is called a quintic polynomial. It's called a quintic polynomial. So this polynomial is called a quintic. Now this type of polynomials also have another naming convention. Sometimes you will see that the linear polynomial is called the first degree polynomial. So instead of linear, it may also be called as the first degree polynomial, right? First degree polynomial. Similarly, the quadratic polynomial can be called the second degree polynomial. So second degree polynomial. The cubic polynomial can be called the third degree polynomial. And the quartic polynomial can also be called the fourth degree polynomial. So I'm going to write it here. Let's say this is our fourth degree polynomial. And then the quintic can be called the fifth degree polynomial. So similarly, if we have, depending on the highest power of x in the polynomial function, the polynomial can be called like, 5th degree polynomial or 6th degree or 7th degree or 8th degree, like that. One more important thing that I should have mentioned upfront is that the value of n must be non-negative integer. So here I'm going to put a quick note here. So our n must be greater than or equal to 0, and n should belong to the integer set of numbers, right? So this is one important note for a polynomial function. Now if this condition is satisfied, then this type of an algebraic expression will be called a polynomial, right? Now let's talk about our quadratic function. So what is our quadratic function? Well, it's the second degree polynomial, right? It kind of looks like this. I'm going to use a different color here. So this is our quadratic polynomial. It looks like this. And now we're going to discuss about the quadratic polynomial. So if we have, say, a quadratic polynomial which is like this, for example, f of x is equal to a sub 2 x squared plus a sub 1 times x plus a sub 0. So here the highest power of x is 2, and that is why it is called a quadratic polynomial function. Now what is a quadratic equation then? Well, when this function or this algebraic expression, which is nothing but a quadratic polynomial, when this polynomial is equated to 0, meaning when the function itself is equated to 0, then it becomes an equation. So this is an equation, right? When we take a function and we say that is equal to 0, then essentially we have created an equation. So similarly, in this case, if we say that x squared or a sub 2 x squared plus a sub 1 x plus a sub 0, if this is equal to 0, then this is a quadratic equation, because we took a quadratic polynomial and we equated that to 0. So this becomes a quadratic equation. Now in our study of quadratic equation, we generally use a different set of coefficients. Here you see we have a coefficient a sub 2 and a sub 1, and also the constant term a sub 0. Now for further study of quadratic equation, we are going to use a different naming convention for the coefficients, and they're going to look like this. So our quadratic equation, the general form of a quadratic equation now going to look like this. So we generally say that it is a times x squared, ax squared plus bx plus c. So we are slightly changing the naming style of the coefficients. So a sub 2 is now being called a sub 1 is now being called b, and a sub 0 is now being called c, and then this is equal to 0. So this is the general form of a quadratic equation. And since we are talking about the polynomial functions here, let's also quickly talk about the 0 of a polynomial. So if somebody says, hey, what is the 0 of a polynomial? So we are going to talk about one topic right here. Let's say it is the 0 of a polynomial function, 0 of a polynomial, right? Now if somebody says, hey, do you know what is the 0 of a polynomial? Well, it's that value of x. So the 0 of a polynomial is actually that value of x which makes the polynomial function, which makes the expression, the polynomial expression, to evaluate to 0. If we have a polynomial function that looks like this, for example, we have let's say f of x is equal to, let's say, a sub 2 x squared plus a sub 1 times x plus a sub 0. Now if we can find a specific value of x where the value of this polynomial function or the value of this polynomial expression will become 0. So when x equals something, for x, if x has a certain value, let's say x equals c, for example, right? I'm just taking it as an example, or maybe x equals p. Let me say x equals p. Suppose we have a certain value of x for which the value of this function which is f of p, which is again a sub 2 p square. Now in place of x I'm writing p, plus a sub 1 times p plus a sub 0. If this quantity, if this expression becomes equal to 0, or if this expression becomes 0, then this particular value, the number p, the real number p, this particular value or this particular number is called a 0 of this polynomial. So this is a 0 of the polynomial, right? So let me write it down. So this particular number, it will be called a 0 of, it is a 0 of f of x. In this example it is f of x, right? So it's a particular value of x for which the polynomial expression will evaluate to 0. That value is called the 0 of a polynomial. Also, let's talk about another nice term which is called the root of an equation. So we are going to quickly talk about the root of an equation. Now if we have an equation like this, if we have an equation, let's say a sub 2x squared plus a sub 1 times x plus a sub 0 equals 0, and if we find a value of x, say suppose x equals p, for example, if we find a value of x for which the equation satisfies, if x equal p would satisfy the equation, if it satisfies the equation, then this will be called x equals p, this will be called a root of the equation. So this will be called, this is the root, this is a root. There may be more than one root depending on the highest power of x. If it is a quadratic equation, there will be 2 roots. If it is a linear equation, there will be 1 root. If it is a cubic equation, there will be 3 roots. So the number of roots actually depends on the highest degree of x in a polynomial, right? So in this case, because it's a quadratic polynomial, because the highest power of x is 2, so there will be 2 roots. But if x equals p satisfies the equation, this is one of the roots. So root of this equation. And also similarly, if we have say another value of x which might satisfy the same equation, say suppose x equals q also satisfies the same equation. If x equals q also satisfies the same equation, then this will also be called a root of that equation. This is just the other root, right? So this will also be called a root of the equation. So x equals whatever value would satisfy the equation, that will be called a root of the equation. I hope everything made sense. Thank you for watching. See you in the next video.